welcome to the video walkthrough for the lab. Leveraging your skills as a CCNA, hopefully most of these tasks you'll be able to do on your own. And that's my primary goal, is to assist you in stretching and making sure that you can pull it off. So before you go through this video walkthrough, take a moment, take the lab, and see how much of it you can do on your own. And then come back and visit me and we'll do the whole thing together. So if you're ready and you've attempted this lab on your own and done parts of it and you want to do the video walkthrough, let's get started right now. Our first order of business is to wipe out every single device. We have 4 switches, switches 1 through 4, and we have 6 routers, 4 shown here and 2 others that we use for practicing. So we wanted to get on the console port, and to verify we're on the console port of each device, we can type in who, and that will show us that we are the asterisk connected to console 0, and that's a good thing. Why? Because we're going to wipe out the entire configuration. Now there's a few ways of doing that. We could just say erase startup config and reload it, and that works. If you're going to script it, however, one technique I often use is I'll save the running config to startup config, then I'll delete the startup config, and then I'll reload it. Why? Because if we save our configuration first, then delete the startup config, and we say reload, it won't prompt us and saying, do you want to save your configuration before you reload? Because if we're trying to wipe out the startup config, and then when we type in reload, we say enter for yes, go ahead and save it, it's going to reboot in 3 to 4 minutes with the same darn config it had previously. So all we're doing here, is what I like to do, is I'm going to do a copy running config to startup config. And instead of actually doing that, I'm going to use the WR command, which is a lot faster and doesn't prompt you to say, are you sure? I'm going to go ahead and save the config. Then I'm going to erase the config. And you can erase the config 2 different ways. You can type in erase space startup config. That works. Or you can type in write erase. That's the old way of doing it. It's also a little bit faster. Write erase simply erases your startup config. So once we've done a write erase, we're then going to do a reload. It's not going to prompt us. It'll simply say, great, as far as do you want to save your config. It'll prompt us saying, are you sure you want to reload? We'll say yes, and boom, we're off to the races. So there's our write. Here's our write erase, and we'll press enter to confirm, and then we'll say reload. And you'll notice it didn't prompt us for, do you want to save your configs? And now we are reloading. I'm going to do this across all 6 routers. And when we come back, after I pause this, they'll all be ready to go. Now there's a slight difference that we need to do for our switches. Let me show you what those are. On the switches, they have something called a VLAN.dat file. And that VLAN.dat file contains all the VLAN information. It also has a file called config.text. If we do a dir, it's going to show us that we've got VLAN.dat here, and we also have a config.txt, and I want to wipe those out. So on a switch, just to make sure it's completely clean, I'm going to do the same technique of saving the config, deleting the startup config. I'm going to use my shortcut of write erase, and then we'll go ahead and reload it. So over here on the switch, we simply go into, they'll say delete VLAN.dat. If it doesn't exist, it'll just give you an error message, but it won't stop the process. Then we're going to delete the config.txt file, have to confirm that, and then we'll go right into the save with the WR, which is equivalent to copy run to start, and then we'll erase the configuration with the write erase. The current way of doing that would be a erase startup config. Same thing, and then we'll do the reload, and we'll press enter to confirm the reload. So the only difference on the switch is that we're going to delete the VLAN.dat and the config.txt. On all the routers, all the switches, we're deleting the startup config, and then we're reloading. So what I'm going to do right here, I'm going to pause because it's going to take like 4 to 5 minutes for all these to come back. And when they come back, we'll start with the lab with task 1A. Alrighty, it's been about 4.5 minutes. The switches and routers have all rebooted. And I'm going to say no to the question, do I want to do the initial startup config? And I'm going to say yes, do you want to terminate the auto install or auto config if it asked me? And it didn't. What'll normally happen is they'll give you a second line asking, would you like to terminate the auto config feature? So I think it may have been long enough where that gave up. So I'll say no, don't want to do the installation configuration script, And no across the board, router 4, no, router 5, no, and router 6, no. And I'll do the same thing for the switches if they're still asking. And they are. So I'll say no to that, and on switch 3, no to that, and finally on switch 4, no to that. And let's go back and just make sure we're in, oh, I missed that one. Then make sure I got switch 3. Guess I had to press enter first, my bad. And switch 2. And switch 1, I think I did press enter on, so it's good to go. All right, and switch router 6 is good to go. Router 5 is good to go. 4, 3, 2, and 1. All right, so now everything is completely wiped back to the factory defaults. VLANs are all gone off the switches. And our first task says that on a piece of paper, this is 1.a, go ahead and draw out the topology as shown in the document. And that's this topology right here. It is really important that you do it. Why? Because as we're going up and down and looking back and forth, you want to have something stable as a foundation in front of you where you can look and say, I'm configuring this device, that port, and make sure you understand what those ports are. So we have switch 1, 2, 3, and 4. Switch 1 is using ports 23 and 24 to go to switch 2. Switch 1 is using ports 19 and 20 to connect to switch 3. And we're also using ports 21 and 22 from 4 to switch 1 as well. Then we have all the other interfaces as labeled, and then we have the wide area network. The frame relay, the puffy clouds here, are frame relay networks. So we have 2 frame relay networks, network 1 and network 2, and we also have a serial point-to-point lease line between R1 and R3. So that's task 1A, is to go ahead and write that out on paper. I've done it. I've done my part. I want you to do it as well. All right, when you're done, we can continue with task 1.b. In task 1.b, it says set up any options that may make your life easier while setting up the network. And I do have a few that make it easier, at least for me. I'd like to share them with you. The first is I really don't like to have to type in config space terminal all the time. And I know config T is a shortcut, but we can also create an alias. An alias, for example, I like setting up the alias of C, that if from exec mode I type in a C, it automatically knows I mean config T, and that's what it logically puts me into, configuration mode. So I'm going to create an alias of C that represents config T. So that's my first little crutch that I'm going to use to make it easier to configure the network. The next thing I'm going to do is I'm going to train the router to not try to resolve a mistyped command to an IP address. See, when you type just a name or something at the command line, if it's not a command it recognizes, it thinks you want to telnet to that name. And as a result, it'll try to resolve that mistyped word into an IP address. Well, by telling it don't bother doing DNS resolution with the no IP domain lookup command, it won't waste time by trying to resolve a mistyped command to an IP address. And so that's my next one we're going to do is no IP domain lookup. All right. Next one that I'd like to do is just to make sure that when I issue a telnet or I try to connect out to a device, if it's TCP based, I'm going to do a 3-way handshake. What if that TCP session isn't going to work? Well, if it's not going to work, let's say I'm trying to telnet to a device where it's not running, I don't want to have to wait up to 30 seconds for the TCP 3-way handshake to complete. I mean, 30 seconds is an eternity. So I'm going to tell the router, listen, if you try to initiate a TCP session, whether it's HTTP or Telnet or SSH, if it's not completing that 3-way handshake within, let's say 5 seconds, go ahead and give up and call it quits. So the command iptcp synwait 5 will tell it to go ahead and wait those 5 seconds. And that's a great thing too. All right, now, I know that we're supposed to have security on our VTY lines and our console port. However, if we're connecting all the time as we're starting to bootstrap the network, it's a pain to have to telnet in and then type enable and maybe put a password when you telnet. So I'm going to tell the line console 0 and the 5 VTY lines to not require a login. And that's with the no login command. I'm also going to specify a privilege level of 15. So the console actually is okay. It's not going to prompt you to log in every time, but the VTY lines will. So on the line console 0, I'm going to say no exec time. That way it won't time out. I'm going to say logging synchronous, which is going to repaint my commands as I'm typing them in if there's a console message that comes up. And I'm also going to say privilege level 15. And that way, when I connect to the console port, I'm in privilege mode, ready to go. I don't have to type enable over and over and over again, which is it's a huge pain. Especially you have lots of devices. You log into one, you go to a different one, you come back, it's timed you out. You have to type in enable again, especially on brand new gear that isn't supporting production traffic yet. So 5 VTY lines, no login required, privilege level 15, good to go. All right, what's next on the list? The last piece I want to do is just for service timestamps. Now, timestamps are a good thing for console messages and logging messages and so forth, but from a training perspective, they just get in the way. So I'm going to turn off my service timestamps for logging and debugging so that they aren't going to bother us or pop up too much and take up additional real estate. That's it. And the last thing I'm going to do is configure a host name on each device. That way, from a CDP perspective, when the interfaces are up, I can verify exactly who is who. So we'll just say host name is going to be R1, and that's good to go. And I'm going to do that same exact process on R2, R3, R4, R5, R6, switch 1, switch 2, switch 3, and switch 4, so that you can expect that same exact behavior regarding TCP SYN weights and domain lookups and so forth. I'm going to pause here just for a moment. I'm going to repeat this exact same process on all other 9 devices. I will probably use copy and paste to do it faster, and then we'll pick up after all of them are configured. You know, for a moment, let's talk about this topology that we're drawing. Here we have switch 1, and we have switch 2, and switch 3, and switch 4. And how this is going to play out is we're going to have switch number 1 on the first floor. And that's going to be in our what's called an MDF, the main distribution frame. And then we're going to have switch 2 on the second floor, switch 3 on the third floor. And here we only have 3 floors, but switch 4 on the fourth and so forth. And our PCs, they're going to be connected with a patch cable into a little wiring jack, an RJ45 jack in the wall. And that's going to have a horizontal run over to the wiring closet where the switches live. So if this is the third floor, that's where switch 3 would be. And then switch 3 is tied down to switch 1 through the vertical run. That's being represented by red. So switch 3 has these 2 FA19 and 20 ports that go down to FA19, 20 on switch 1. And on switch 1, we can call that an aggregation switch, if for lack of a better term. And then this cabinet right here very likely is going to house this router that's going to do our inter-VLAN routing for any of the VLANs that we create. So I just like to give you a visual representation of the physical building and how it's going to be used in conjunction with our gear that's already been wired. So the next task is 1.c to implement trunks between switch 1 and the other 3 switches as shown in the table. Now the table is just representing in the document, it's just representing what we see here in the physical topology anyway. So we have a trunk. It looks like we're going to use ports 19 through 24 on switch 1, and then ports 23, 24 on switch 2, 19 and 20 on switch 3, and 21 and 22. Just to verify that we're connecting to where we think we're connecting, we could do a quick show of CDP neighbors just to verify that those are physically connected where we think they are. Now, the reason this is not showing any neighbors is because I'm on router 1. Half of the trick of getting the job done is going to the right device. So we'll go over to switch 1 and we'll issue the same command, which is show CDP neighbors, and verify that we have switch 2, switch 3, and switch 4 off those ports. Now look at this. This is showing us that we have, oh, and those are almost timed out. I just recently, as you know, I renamed these switches from switch, the default name, to switch 1, switch 2, switch 3, switch 4. Look at the hold time. Within another 58 seconds from when I issue this command, that entry will be completely removed because that's the CDP advertisement from over a minute ago that advertised this guy as switch. Now that's 2122, which is really switch 4. So that's switch 4's old advertisements before he got renamed. If I've waited long enough and we do that same command again, we should have almost there. 17 seconds to go, and then we'll have a clean shot. But let's just verify that our pairs are there. So switch 2 should be on our local 23 and 24, which it is, was a switch 1's perspective. And switch 3 right here should be on ports 19 and 20, which it is. That's a good sign. And switch 4 is on ports 21 and 22. And it's just so convenient because we're using the same exact ports on both sides. So that's terrific. So our first thing we can do, now that we know we have those connections in place, is we can configure trunks. If we want to force, let's see, it says they want us to use .1Q encapsulation. And so we can just go ahead and implement that. Super easy. Here on switch 1, we just go to configuration mode. We use interface range 19 through 24 for the interfaces. Tell them all that we want to use .1Q encapsulation, and tell them all that we want them to be trunks. It's really that simple. Now, by default, switch ports are up. We also verified that we have CDP working, which verifies the interfaces are working, and we're done. Now we've got those 4 switch ports right here on switch 1 configured. The next step would be to go to switch number 2. So we just trot over to the right switch, switch number 2, and do the same thing there, except now on switch 2, we're going to be using just ports 23 and 24. So we configure those 2, and switch 2 is good to go. We'll do the same thing on switch 3. We'll verify all this, by the way, just to make sure it's all working. So switch 2 gets encapsulation.1Q and switch port mode trunk. Fabulous. And then we'll go to switch 3 and do the same exact thing. Except on switch 3, we're going to be using ports FA 19 and 20. So we'll configure the right ports there. And then finally, we'll go to switch number 4 and do similar treatment. So switch port trunk encapsulation .1Q says, if you're going to be a trunk, use .1Q. And switch port mode trunk says, hey, you get to be a trunk. Congratulations. And finally, we'll go to switch 4 and configure him. So here on switch 4, same thing. Interface range for 21 and 22. Switch port trunk encapsulation .1Q and switch port mode trunk. Now, one of the secrets of building a successful network is to verify it in baby steps. So we're going to go back to switch 1 here in a moment when we're done with this configuration. And on switch 1, we'll simply verify that our trunks are really configured as trunks. So that's the end of switch 4 for configuration-wise. We'll go back to switch 1 and do a show interface trunk. And we should have 6 trunk ports. And there they are. 1, 2, 3, 4, 5, 6. That's great. And we only have VLAN 1, so we're forwarding for VLAN 1 in all of those. Which is, well, actually, are we? Let's take a look. We are forwarding for all of those for VLAN 1. Okay, that's great. Task 1.d says that once the trunks are in place, shut down any other ports not listed in the table or in the topology here that directly connect switches 1, 2, 3, and 4. So we want to disconnect any cabling that, or logically shut it down if it's interconnecting switch 2, 3, or 4 based on the design. So we'll say, great, how do we verify that? Here on switch 2, let's just do a show CDP neighbors. That'd be a great test. We should only have connections to switch 1. And check it out. We've got connections to switch 4, and we've also got connections to switch 3. So we're going to need to shut down those ports. Looks like we have a full mesh of connections between all of these devices. Now, could we leave them all up and let Spanning Tree fight it out? Yes, we could. But based on the design, they want 2 connections from switch 1 to 2, 2 from 1 to 3, and 2 from 1 to 4. We're going to go ahead and give them what they want. So on switch 2, if we want to shut down ports 21, 22, and 19 and 20, we can do that in ranges. That'll work. So we'll go into configuration mode and say interface range, FA 19 through 20, or excuse me, 19 through 24. Let's do this. Let's shut down all of them, and let's just bring up the ones we want, which is 23 and 24. So, you know, 6 one way, half a dozen the other, that'll work. So we shut down everything, and then we just brought up the 2 that we need, 23 and 24. And that works. Let's do the same thing on switch 3. On switch 3, let's find out who our CDP neighbors are. And our CDP neighbors, in fact, I happen to know, because I know this topology, we have a whole bunch of connections between every device. So we need to remove ports 23 and 24. So I'm going to do the same thing. I'm going to do an interface range and shut them all down. And then I'm simply going to bring up the ones that we need. So switch 3 only needs 19 and 20. So I'm going to shut down 19 through 24 and bring up 19 and 20. And that way we'll just get the ones up that we need. I'm going to do the same thing on switch 4. So on switch 4, we'll shut down all the ports from 19 through 24 and then bring up just the 2 that we need. So we'll go to switch 4 and do exactly that. So basically how it works is these 4 switches, based on how they're cabled, 19 through 24 are all in use on all devices, which allows for some interconnectivity between switch 3 and switch 4 and switch 2 and switch 3. So we're simply shutting down all the ports from 19 through 24 on these 3 switches and then bringing up just the 2 that we want to be in use. So on switch 4, if we wanted to do a show interface trunk, we should have in our trunk simply FA 0/21 and 22, which is what we do. You also notice that we have, wow, look at this. VLANs in spanning tree forwarding state and not being pruned. We are not forwarding at all. Let's give a moment for spanning tree just to rethink that. And let's talk about that for a moment. What would cause spanning tree to not forward traffic? Well, we just shut all these interfaces down on switch 4 and we brought them back up. So by default, how long does it take for spanning tree to allow forwarding on a port? And the default answer is 30 seconds with 802.1d standard spanning tree. It takes 15 seconds for the listening and then 15 seconds more for the learning state, and then it can start forwarding. So if we wait a full 30 seconds, now that these interfaces are up, we should have at least one of these interfaces that is in a forwarding state. So we'll do a show interface trunk, and there we go. So FA 0/21 is forwarding, 22 is blocking. Why is that? Well, it's because this switch is not the root. If it was the root, it would be forwarding on both. So our switch 4 identified who the root was. It's one of these other switches. It said I've got parallel paths because I see BPDUs coming in on 21 and 22. And as a result, I need to block on one. And so it chose the lowest numbered port, which is very typical if we left everything to the default, and it's forwarding on just that one interface. That's great. So we at least have our trunk active and we're forwarding on at least one interface. So each of these devices has at least one interface forwarding between each itself, switch 2, 3, and 4, and switch number 1. Our next task, 1.e, asks us to make switch 1 the root for spanning tree for VLANs 1 through 50. Now we only have VLAN 1 so far, but if new VLANs come up that we create, we want them to be the root there as well. So let's find out who the root is. How do we find that out? We can do a show spanning tree for VLAN 1. Now we only have VLAN 1, so I could have just said show spanning tree. So there's the command we just issued, and we are not the root. Check this out. Who is the root? Now there's kind of a weird cost here. We're using gigabit 0/2 as our root port. Now, frankly, I don't see gigabit 02 as one that's supposed to be used here. So we've got this rack of gear, and we have something that lives off gig 02. That's the root of spanning tree. Let's fix that. We do not want that. How do we find out who's out there? We do a show CDP neighbor. That's one way of finding out. We could also use a link layer discovery protocol if it was running. And this shows that we have this guy, which is a 3750 switch living off of this port gig 0/2. Now that's not going to be used in our topology. We could, I suppose, make our root better, a better priority than whatever this guy is, because right now he's got a priority of 100. That's pretty darn low. Let's just close off that port, because this is very real world. If you didn't put the cabling in place, you could have a whole bunch of connections to devices that perhaps weren't intended. So because it's not part of our topology, I'm going to shut it down. We're going to go into interface gig 0/2 and do a shut. Now spanning tree only takes a few moments to reconverge. So now that we've done that, we can do a show spanning tree for VLAN 1. Let's see if we're the root. Look at that. It says we are the root for VLAN 1 and we're designated. Now how can we, that's terrific. That's wonderful. So we don't do anything else. Let's just give it a few more moments. Do a show spanning tree again. Look at that. My hands never left my arms. But while spanning tree was converging, And while it was going, it had blocking ports and alternate ports and everything else. Because it's not rapid spanning tree, it was still converging when I did the first show. And at the moment before it converged, it thought it was the root of the world because it lost the previous root. But upon seeing additional BPDUs come in, it discovered that it wasn't the root. So even though we issued a show spanning tree and it said, I'm the root, that was because this guy had not fully converged with the rest of the network. Now he has, and his root port is now out FA0/19. So switch 1 thinks that the root is off this port, which and it only costs 19 to get there. So basically, our switch 3 is the root, and we need to be the root. So switch 3 just probably has a better base MAC address than we do. So there's its base MAC address. Here's our base MAC address. The default priorities are the same, and sure enough, his is lower. So how do we fix that? We're going to fix that by simply forcing it. We'll specify spanning tree root and a priority of 4096, and that'll take us to King Kong position. So super easy to do. Spanning tree for VLAN 1 through 50, I want the priority to be 4096. And now we win. So in just a few moments after everybody else figures out, ooh, golly, the topology's changed, if we do a show spanning tree, and we only have one VLAN, so I don't need to put VLAN 1 in, it's going to show us that we are now the root. And check it out, we're going through the listening and learning states on that port, and we're still going to win because our priority is the best on the block. Like golf, the lowest score wins. So that was task number 1.e, to configure switch 1 to be the spanning tree root for VLANs within the range of 1 through 50. And if we took a look at the other switches, they would all concur that their root ports would be one of these two and lead to the switch 1, who is indeed the root of spanning tree for VLANs 1 through 50. Our next task is to configure VTP, the VLAN trunk protocol, to be used on all 4 switches using the information in the table. And basically it's saying that the VTP domain needs to be Nova Datacom for all of them. The password should be Cisco123 for all of them. And switch 1 should be a server, and switch 2, 3, and 4 should be clients. Now let's recall what the benefit of using VTP is. If we have one giant VTP domain and switch 1 is the server, if we create a brand new VLAN like VLAN 70, automatically VLAN 70 will show up on all the other switches. It doesn't mean that access ports are assigned to that VLAN. It simply means that the other switches are aware that VLAN 70 exists, and that's the end of the story. So if we turn on other features like pruning and so forth, we can turn that on the server, and the entire VTP domain will buy into it. So let's start off on switch number 1. And on switch number 1, to turn on VTP or to change the domain name, we'd say VTP domain and then call it Nova Datacom. We're also going to set a VTP password of Cisco123. Why? Because that's what the task asks to do. And the default mode is server. If we go over to switch 2, we'll do the same treatment, except on switch 2, we're going to set it up as a client. So we'll need to do the configuration and then add the piece of VTP client. Notice the VTP user notification that we had an MD5 digest checksum mismatch. And that's because we had configured MD5 on switch 1, a password effectively, and it was sending updates and switch 2 didn't have it. One thing I didn't do here, which we need to do, is VTP mode, and we'll say client and save our config. All right, all we have to do is repeat that on switch 3 and switch 4. So on switch 3, we simply tell what domain it belongs to, what the password is, and its mode, and we are halfway home. And look at that, switch 3 says it was already set to Nova Datacom. I must not have successfully deleted everything from a VTP perspective. Oh no, what's that here? Here's what's likely happened. I had switch 2 configured. On switch 1, here's what very likely happened. On switch 1, we configured a domain name of Nova Datacom. When I did that, it sent out an update, and switches that were not yet configured with a VTP domain name, they took that name. And then after I configured a VTP password, that's when my communication stopped. So that's why it was already set to Nova Datacom. In fact, let's go over to switch 4 before we do any configuration and do a show VTP status. And check this out. It has the VTP domain name of Nova Datacom. So I really don't even have to add the VTP domain name because it already knows it. I can simply say it's client and specify what the password is. So it's an order of operations thing. So we'll leave off that step, no big deal. Config T, VTP password, Cisco 123, and VTP mode client. And we're set. All right, I'm going to save my config here as well, just because that's a good thing to do periodically. Do with a real quick WR, which is equivalent to copy run start. And that is it, my friends, for 1.f. Now, how do we verify that? That's a critical piece. Every time we do something, we want to verify and check it. Well, theoretically, we should be able to create a new VLAN on the switch, and that new VLAN should show up on all of the other switches. So let's try that out. Let's go to switch 1 and say VLAN 70, which didn't exist before. And we'll do a show VLAN 70. Actually, let's just do a show VLAN brief. That'll work. So there's our VLAN 70 right there. No access ports assigned to it, but the VLAN exists. And theoretically, all the other switches, we can pick any one of them, it should know about it as well. And there you have it. Same thing if we delete it. If we go back to switch 1 and say no VLAN 70 and delete that broadcast domain that no one was using anyway, we should be able to go back to the other switches and it should be gone. And there it is. So it was right there, and it's not anymore. So VTP is successfully working in our environment. And to verify, of course, we could do the show VTP status and see all the details about exactly how it's configured. We're a client. Here's our current configuration revision number. Here's the MD5 digest. It needs to match on all of our updates that we get. Otherwise, we won't buy into them. And there's our VTP domain name. One really cool thing is that if you want to see the password, it's not in the config. It's not in the running config, but you can see it with a show VTP password if you're curious about what it is. So if you have to change it or add a new switch and you forgot what the password is, instead of changing the passwords on all your switches, just go to one switch that has the VTP password, do a show from privilege mode of VTP password, and you're good to go. So there you have it. VTP successfully configured, and that's task 1.f. Our next task, which is 1G, is to go ahead and create the following VLANs in addition to port assignments for those VLANs. So it's two separate steps. We need to create the VLANs 10, 20, 30, and 40, and 50 and give them the appropriate names. So where are we going to do that? Well, all we need to do is go to the server, the VTP server, and that's where we create all of our VLANs, and they'll automatically propagate as exist anyways on all the other switches in the VTP domain. So we'll go to switch 1 and go into configuration mode and carve out VLAN 10, give it a name because they asked us to. And we'll do the same thing for VLAN 20, VLAN 30, VLAN 40, and VLAN 50. So let's just hammering them out. If we didn't give them a name, they'd have a really generic name like VLAN 00020, something to that effect, or VLAN 00030. So what is a VLAN again? A VLAN is nothing more than a layer 2 broadcast domain. So you might ask, well, how far does VLAN 10 go? How wide is that broadcast domain? And the answer is that doesn't go anywhere yet because you have to assign ports to VLANs to make them useful, or at least you have to assign logical layer 3 interfaces to VLANs to make them useful. So at the moment, these VLANs just exist, but no one is taking advantage or using these broadcast domains at the moment. So there's our show VLAN brief right here. And here we have the VLANs 10, 20, 30, 40, and 50. And over to the right, we have all the ports assigned to them, which is nothing because all the ports are assigned to VLAN 1 by default. If we go to switch 2 and we do a show VLAN brief, check this out. Through the magic of VTP, we have those VLANs. They all exist, but just as before, there's no ports assigned to them. So port assignment is a personal thing. Each switch can assign ports to individual VLANs, but as far as sharing that a VLAN exists, VTP can propagate that very quickly across the entire VTP domain. And that's it for 1G. I spoke too soon. I said, oh, 1G is over, and I look back at 1G and it says, create the following VLANs using the information provided in the table. The table also shows which ports are assigned to which VLANs. So that's the second step that we have to visit each switch to do. So on switch number 1, I'm going to go ahead and specify that for interfaces 2 through 4, that they're access ports and they're assigned to VLAN 10. Why? Because that's what they asked to do as we configured it. So think of it this way. We're going to have on switch number 1 some ports assigned to VLAN 10, other physical ports assigned to VLAN 20, other physical ports assigned to VLAN 30, and other physical ports assigned to VLAN 40. We're going to do that same exact behavior on switch 2, switch 3, and switch 4. So maybe the finance department has a couple people on the 3rd floor and a couple people on the 2nd floor, and we can physically put them in ports assigned to their appropriate VLAN, and as a result, they would all be in the same layer 2 broadcast domain. So that's how it fits. So switch 1, ports 5 through 8, that's going to be assigned to VLAN 20, and 9 through 12 are going to be access ports, meaning don't let your client try to negotiate a trunk. It's an access port assigned to one VLAN, and we're going to assign 9 to 12 to VLAN 30, and then ports FA0/13 through 16 are going to be assigned to VLAN 40 as access ports. Now, I want to make a very clear distinction here. All these 4 switches, they all know about the 4 VLANs, actually 5 VLANs, VLANs 10 through 50. But only switch 1 has ports assigned to any of them. So let's take a quick look here on switch 1 with a show VLAN brief. Check this out. Show VLAN brief shows us that we have these VLANs and we have specific ports assigned to it. 2 through 4 assigned to VLAN 10, 5 through 8 assigned to VLAN 20. Now, if we go over to another switch, let's just pick switch 4 as an example, and we do that same exact command of show VLAN brief, just like this. You'll notice that we have the VLANs, but from our switch 4's perspective, because assigning ports to a VLAN is a local deal, switch 4 doesn't have any of his local ports assigned to any of those VLANs yet. So the task wants us to take the ports 2 through 4 on all switches and make them assigned to VLAN 10, and 5 through 8 and assign them to VLAN 20, and 9 through 12 and assign them to VLAN 30, and 13 through 16 and assign them to VLAN 40. So we're going to do pretty much that same exact configuration on each of the switches. So let's just do it on one more, and then I'll do the other 2 in the background so you don't have to watch it over and over again. Hopefully, by the way, you are doing this yourself. That's the intention of this lab, is to give you the practice in doing it. So let's go to switch number 2. And on switch number 2, we'll go into configuration mode, and we'll simply assign out the ports. In fact, this is going to be the exact same configuration that we did on switch 1, where you just happen to have the same port assignments. So ports 2 through 4 are access ports in VLAN 10, and 5 through 8 in 20, and 9 through 12 in 30, and 13 through 16 in VLAN 40. And we'll repeat that process on switch 3 and switch 4. So while we're finishing this config, devices that connect, let's say, for example, that we connect a device to FA0/2 on switch 2. That device, whatever it is a printer, it's a workstation, it's a server, because port 2 is assigned to VLAN 10, any traffic that comes in on that port number 2, is going to be considered by the switch to belong to or be a part of VLAN 10 traffic. And that's how the switch, the layer 2 switch, is controlling who belongs to which broadcast domains, is based on port assignments. And then as we connect devices to those ports, whatever traffic, whatever packets, whatever frames come in are going to be associated and a member of that VLAN. So another thing we could do as well is a client who's on VLAN 10 here, if he sends a broadcast into the switch is going to forward that broadcast down the trunk ports, tag it as VLAN 10. A switch downstream is going to get that frame, say, oh, I need to forward this to all my VLAN 10 interfaces, as well as forward it out any other trunks who also might have need for a broadcast for VLAN 10. So same process on switch 3 and switch 4. I'm going to configure switch 3 and switch 4 with exactly that same configuration of the access port assignments, and then I'll come right back.